During a kitchen remodel, encountering unexpected electrical setups, like a buried and uncovered junction box, is not uncommon in older homes. Finding such a concealed enclosure raises immediate concerns about safety and code compliance. Several approaches exist to address this situation, each with varying degrees of permanence and adherence to electrical codes. The first option involves using a metal cover. Yes, covering the existing enclosure with a metal cover cut to fit is a possibility. However, it's crucial to ensure the cover is effectively grounded to the ground tap within the enclosure. This measure is best regarded as a temporary solution, not a permanent fix, since it doesn't fully address the underlying issues of the non-compliant enclosure. The second option involves an aluminum angle and cover. This is similar to the first but offers a more robust approach. By using aluminum angles to create a frame around the existing enclosure, a custom-cut aluminum cover can be secured to this frame. Again, grounding the aluminum frame to the enclosure's ground tap is vital. This method offers a more secure and aesthetically pleasing temporary solution. The third option involves gutted circuit breaker enclosure replacement, and this is typically the most recommended solution. This approach, while more involved, is the most code compliant and provides a permanent resolution. It involves several steps. Firstly, the existing enclosure, along with the pins securing it to the wall, should be carefully removed. Secondly, a new gutted circuit breaker enclosure is installed in the same location. Thirdly, the wires are transferred from the old enclosure to the new one, ensuring each connection is secure. Finally, the connections should be inspected to ensure they meet current electrical code requirements. The fourth option involves plywood. This option is generally not recommended. Using plywood as an electrical enclosure is typically not an approved method. If pursued, the plywood should be at least 3/4 of an inch thick and grounded to the enclosure's ground tap. Remember, this is a temporary measure and should be replaced with a code-compliant solution as soon as possible. Now let's cover some legal considerations. All electrical work should be performed by a licensed electrician. Any modifications to an electrical system must comply with local electrical codes. Failure to adhere to these codes can result in safety hazards and potential legal repercussions. When faced with such a scenario, several factors must be considered to ensure the safety and legality of the electrical system. Firstly, the existing conditions, like the presence of multiple conduits entering the enclosure and the lack of a proper cover, immediately raise concerns about compliance with current electrical codes. Secondly, the age of the house built in the 1950s suggests that the existing electrical system may not meet modern safety standards. Therefore, any modifications should aim to bring the system up to code. Thirdly, the location of the enclosure hidden behind drywall indicates a potential fire hazard and makes it difficult to access for maintenance or repairs. Therefore, the solution should provide easy access while ensuring safety. Fourthly, the presence of numerous cross-connections within the enclosure highlights the need for a safe and organized wiring solution. A haphazard arrangement of wires can increase the risk of shorts and other electrical problems. Fifthly, the method of securing the enclosure to the concrete wall with explosive steel pins presents a challenge for removal and replacement. Therefore, any solution should consider the difficulty of working with this type of mounting system. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations to ensure safety and prevent fire hazards. Several articles within the NEC are particularly relevant to this situation. NEC Article 110.3 addresses examination, identification, installation, and use of equipment. This section requires that all electrical equipment be installed and used according to the instructions included in a listing or labeling. In this case, any replacement enclosure must be suitable for use as a junction box and installed according to the manufacturer's instructions. NEC Article 312 covers cabinets, cut-out boxes, and meter socket enclosures. This article provides requirements for the construction, installation, and use of these enclosures. It specifies that enclosures must be securely fastened in place and provide adequate space for conductors. It also requires that enclosures be readily accessible, which is not the case with the existing buried enclosure. NEC Article 314 covers outlet, device, pull, and junction boxes, conduit bodies, fittings, and handheld enclosures. This article provides requirements for the selection and installation of these boxes and enclosures. It specifies that boxes must be of sufficient size to accommodate the conductors and devices installed in them. It also requires that boxes be securely supported and accessible. NEC Article 408 covers switchboards, switchgear, and panel boards. While the existing enclosure may not be a panel board in the traditional sense, this article provides relevant requirements for the installation and wiring of electrical distribution equipment. It specifies that panel boards must be protected from physical damage and installed in a readily accessible location. NEC Section 110.12 addresses mechanical execution of work. This section requires that electrical work be performed in a neat and workmanlike manner. This includes properly supporting and securing conductors, making tight connections, and avoiding damage to equipment. In the scenario presented, the best course of action would be to replace the existing enclosure with a new, code-compliant junction box. This would involve carefully removing the existing enclosure, installing a new box of the appropriate size, and properly terminating all conductors within the box. The new box should be securely mounted and readily accessible for future maintenance. If it is not possible to replace the existing enclosure due to the difficulty of removing it from the concrete wall, the next best option would be to install a cover over the enclosure to provide protection and prevent accidental contact with energized parts. The cover should be made of metal or another approved material and securely fastened to the enclosure. It should also be labeled to warn of the presence of energized parts inside. If installing a cover, the enclosure should also be inspected to ensure that all conductors are properly terminated and that there are no signs of damage or deterioration. Any necessary repairs should be made to ensure the safety and reliability of the electrical system. Regardless of the approach, consulting with a licensed electrician is crucial to ensure that all work is performed in accordance with the NEC and local electrical codes. They can assess the existing conditions, recommend the appropriate solution, and perform the work safely and effectively. When dealing with electrical systems, safety should always be the top priority. Working with electricity can be dangerous, and it is important to take precautions to avoid shocks, burns, and other injuries. Always disconnect power before working on any electrical equipment, and use appropriate personal protective equipment such as rubber gloves and safety glasses. If not comfortable working with electricity, it is best to leave the work to a qualified electrician. Here are some considerations for each plan, especially in light of code compliance and long-term safety. For Plan A, a metal cover may seem like a quick fix. It falls short of meeting code requirements for electrical enclosures, particularly regarding accessibility and protection against accidental contact. While it might temporarily conceal the wires, it doesn't address the underlying issues of a non-compliant enclosure. For Plan B, while adding aluminum angles and a custom-cut aluminum cover offers a more secure and finished appearance than a simple metal cover, it still doesn't fully meet code requirements for electrical enclosures. The enclosure remains inaccessible and may not provide adequate protection against physical damage or environmental factors. For Plan C, replacing the existing enclosure with a gutted circuit breaker enclosure is the most code-compliant and safest option. It involves removing the old enclosure, installing a new one that meets current standards, and properly terminating all conductors within the box. This ensures accessibility, protection, and compliance with the electrical codes. For Plan D, using a plywood cover is not recommended as it doesn't meet code requirements for electrical enclosures. Plywood is combustible and doesn't provide adequate protection against electrical hazards. It's a temporary fix at best and should be avoided in favor of a more suitable solution. Some additional factors to consider. Firstly, the age of the wiring. Given the age of the house, the wiring within the enclosure may be outdated or damaged. Replacing the wiring along with the enclosure would ensure a safer and more reliable electrical system. Secondly, grounding. Proper grounding is essential for electrical safety. Make sure that the enclosure and all electrical components are properly grounded to prevent electrical shock hazards. Thirdly, labeling. Clearly label the enclosure on all circuits to identify their purpose and voltage. This helps prevent confusion and ensures that future maintenance or repairs can be performed safely. Finally, inspection. After completing any electrical work, have it inspected by a qualified electrician or electrical inspector to ensure compliance with codes and regulations. Additional tips include: firstly, photograph everything before starting. Take detailed photos of the existing enclosure, wiring, and connections before starting any work. This serves as a valuable reference during the replacement process. Secondly, use the right tools. Use appropriate tools for electrical work, such as insulated screwdrivers, wire strippers, and voltage testers. This ensures safety and prevents damage to electrical components. Thirdly, take your time. Electrical work should be approached with caution and attention to detail. Avoid rushing through the process and double-check all connections before energizing the circuit. Let's consider the specific types of conductors to consider. If the original wiring is cloth insulated, it's nearing the end of its service life and should be replaced where possible. Modern wiring like THHN or THWN is much safer and more durable. When replacing conductors, ensure the wire gauge is appropriate for the circuit's amperage. Using undersized wires can lead to overheating and fire hazards. Furthermore, when making connections, use properly sized wire connectors such as wire nuts or terminal blocks. Ensure that all connections are tight and secure to prevent loose connections and arcing. Remember to properly bond the metal enclosure to the grounding system to provide a path for fault current in case of a short circuit. Use a grounding screw or lug to connect a grounding conductor to the enclosure. Also, consider adding a surge protector at the main panel to protect against voltage spikes and surges, which can damage sensitive electronic equipment. When working in tight spaces, a headlamp or flashlight can be invaluable for illuminating the work area and making it easier to see connections. Also, consider the long-term maintenance of the electrical system. Installing a readily accessible enclosure with clear labeling makes it easier to inspect and maintain the system in the future. Furthermore, make sure to document all electrical work performed, including wiring diagrams and circuit schedules. This information can be helpful for future troubleshooting and repairs. When selecting a replacement enclosure, choose one that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or UL. This ensures that the enclosure meets safety standards and is suitable for its intended use. If the existing enclosure contains any hazardous materials, such as asbestos, take appropriate precautions to protect yourself and others from exposure. Consult with a qualified environmental professional for guidance on handling and disposal of hazardous materials. Also, consider the aesthetic appearance of the electrical enclosure. While functionality and safety are paramount, choosing an enclosure that blends in with the surrounding decor can improve the overall look of the space. Furthermore, when routing conductors through conduit, ensure that the conduit is properly supported and secure to prevent damage or strain on the wires. Use conduit clamps or straps to secure the conduit to walls or ceilings. Remember to protect conductors from physical damage by using appropriate fittings and connectors. Use bushings or grommets to protect wires from sharp edges where they enter or exit enclosures. Also, consider the environmental conditions in the area where the electrical enclosure is located. If the enclosure is exposed to moisture or corrosive substances, choose an enclosure that is rated for wet or corrosive environments. Also, consider the load requirements of the circuits that will be connected to the enclosure. Make sure that the enclosure is large enough to accommodate all of the necessary conductors and devices without overcrowding. When working with electrical circuits, always use a voltage tester to verify that the power is off before touching any wires or terminals. This helps prevent electrical shock and injury. Also, consider the potential for future expansion of the electrical system. Choose an enclosure that has enough spare capacity to accommodate future circuits or devices. In the event that the explosive steel pins cannot be removed without causing significant damage to the concrete wall, consider using alternative mounting methods, such as epoxy adhesives or concrete anchors. If the existing enclosure is recessed into the wall, make sure that the replacement enclosure is also recessed to maintain a flush appearance. Furthermore, consider the accessibility of the electrical enclosure for people with disabilities. Install the enclosure to height that is easily accessible to people in wheelchairs or with limited mobility. Remember to comply with all applicable building codes and regulations when performing electrical work. Obtain the necessary permits and inspections to ensure that the work is done safely and legally. After completing the electrical work, test all circuits and devices to verify that they are working properly. Use a multimeter to check voltages, currents, and continuity. Also, consider the impact of the electrical work on other building systems such as plumbing, HVAC, and structural components. Coordinate with other contractors to ensure that the electrical work does not interfere with these systems. When selecting conductors, choose those with the appropriate insulation rating for the voltage and temperature of the circuit. Use conductors with a higher insulation rating for circuits that operate at higher voltages or temperatures. Also, consider the color coding of conductors when making connections. Use black wires for hot conductors, white wires for neutral conductors, and green or bare wires for grounding conductors. Furthermore, consider the use of arc fault circuit interrupters, or size, to protect against arc faults, which can cause fires. Install a size on circuits that serve bedrooms, living rooms, and other areas where people may be sleeping or spending time. Also, consider the use of ground fault circuit interrupters, or GFCIs, to protect against ground faults, which can cause electrical shock. Install GFCIs on circuits that serve bathrooms, kitchens, and other areas where water may be present. Furthermore, consider the use of surge protection devices, or SPDs, to protect against voltage surges which can damage electronic equipment. Install SPD at the main electrical panel and at individual circuits to provide comprehensive surge protection. Also, consider the use of energy-efficient lighting and appliances to reduce energy consumption and lower utility bills. Use LED lighting, Energy Star appliances, and other energy-efficient products to save money and conserve resources. If the existing electrical system is outdated or inadequate, consider upgrading the entire system to meet modern safety and performance standards. Replace old wiring, panels, and devices with new, code-compliant equipment. It is important to note that electrical codes and regulations vary depending on the location. Consult with local authorities or a qualified electrician to ensure compliance with all applicable requirements. When in doubt, it is always best to err on the side of caution and seek professional assistance. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. Prioritize safety, compliance, and long-term reliability when addressing this electrical enclosure issue. Option 3. Replacing the enclosure with a gutted circuit breaker enclosure offers the most comprehensive solution for ensuring a safe and code-compliant electrical system.